welcome to Hexagon's fourth webinar, Supporting Formula and Baja SAE Student Teams. Today we have Christian Kuchek, who regularly offers trainings in Adams View and Adams Car. He is an Adams user of nearly 10 years, and today's webinar will be on how to use Adams Car for chassis suspension assembly design. And with that, I'll turn it over to you.
Thank you very much for introduction, Alex, and of course, welcome to everyone for such a webinar. I'm very excited that I can contribute to such great webinar series, and of course, here to you with this challenging project, which is the Formula SAE competition. Today, I will be presenting the multi-body dynamic simulation with Adams Car for Formula SAE competition, and mainly focusing on the suspension analysis. So just let's get started with it. Short agenda for our presentation. So I will be starting with a brief overview of the multi-body simulation. Afterwards, I would like to introduce Adams Car and its capabilities, switching to the basic concept into Adams Car, and what is the goal of our presentation is exactly the suspension assembly. So I would like to tackle topics like how to build a suspension in Adams Car, how to analyze it, of course, run the first simulation, get the results and post-process them. And in the end, I will be demonstrate that based on the Formula Student front suspension system, including steering and anti-roll bar. And last but not least, we will talk about how to access the software, and we will be finalizing our webinar into Q&A session. What is a multi-body simulation? Simply speaking, multi-body simulation is a motion analysis based on the complex system. Yeah, so multi-body model consists of the parts, constraints, so they are connected to each other for sure. Of course, we have external forces into it, connected to it. Of course, we can then let's say use the strong CAD interface, where you will be able to import your CAD geometry, and based on the CAD geometry, incorporate the mass and inertia tensor. Of course, do not forget that during the multi-body analysis, you will work with the large angles, large displacement, and of course with the nonlinear forces, also including contact and friction. Do not forget that multi-body simulation enables you to perform the system level analysis. So it's simply speaking a study of interaction between multiple components or multiple subsystems, like we have in our car vehicle model, where you are dealing with the front suspension, rear suspension, the chassis itself, and so on. Of course, after running the analysis, you will get then results, and these results can be then post-processed via animation and plots to highlight the kinematics or dynamics based on the boundary conditions they are set it up for your multi-body model. Why you are using Adams? Yeah, because it has a long footprint in many industries, over 40 years of innovation and leadership. Adams is mostly widely used as mechanical system simulation software in aerospace, in heavy machinery, medicine, or even defense and space, and of course in automotive industry. So of course, like many OEMs is using everyday Adams to solve various vehicle dynamics problems. Next, I would like to highlight Adams portfolio in case of automotive industry, because for that the Adams Car will be then used. So of course, when we are dealing about the usage of simulation for car analysis, we would like to highlight some handling and ride analysis to understand how our vehicle behaves under different boundary conditions. We would like to accelerate, we would like to perform some braking analysis itself, and see what about the performance, which is then getting out in our result. The second one is, for example, the driveline type of analysis, when you can build up the complex driveline system in your full multi-body model of your car, and again ride with that on various road surface to see the effects on the dynamic analysis. Last but not least, of course, durability study. It's also the key input for our analysis when you would like to see the flexible bodies in action. For example, like the rear suspension where the twist beam was incorporated. And by doing that, you will be able to see the deformation or even the stresses results directly in ADAMS based on the durability plugin activation. If you would like to, it's also possible to tackle the full vehicle ADAMS car model into real-time analysis and run your multi-body model on the driving simulator, or even connect the environment to check how about the sensor are included in chassis can have influence of your testing in case of autonomous driving. But yes, let's come back to the topic for today's webinar. So we have, of course, generic question. As an engineer in the Formula student team, you may ask, where do I put the suspension hardpoints? Hardpoints mean the locations of our main components. Does the new design handle better than the previous one? What about the performance? What should be the toe and camber angle setup for my suspension assembly, front axle on the rear axle in this respect? And what about the loads I'm getting after the simulation is done? And these answers can be then provided by ADAMS, or simply speaking by ADAMS car, which is the vertical product in case of vehicle dynamics. And this helps you answer these questions in case of suspension geometry and kinematic and compliance design. You will be able to run the full vehicle handling simulation as well to check the completed behavior of your model on the various type of the analysis. It could be the single lane change, double lane change, the safety the safety cases as well, to prepare also or get even the loads after analysis and investigate them for component design. Next, ADAMS car. So we are let's say diving up into the topic. So what is it specifically? So our main goal is to build up our vehicle, our car model. And as you can see in the middle of the picture, we have, like, let's say the car model, but of course we have a separate sub-components or even the subsystem. In ADAMS car, we are calling them subsystems. And based on that, of course, you need to have all separate subsystems, and in the end, they will be merged together into one vehicle, like the steering subsystem, like a powertrain subsystem, front suspension together with the tires, and the same for the rear axle as well. ADAMS car enables you to get the library of models directly from the installation. In ADAMS car, you will be able also to customize, if needed, the already prepared simulation analysis. You will be, in the end, able to run the different test events, like cornering events, like a skid pad events, if you want. Of course, different events are applying to the different requirements that you need to fulfill. And when the simulation will be then ready, you will be able to get or do the post-processing and get the standard reports, which are also available in the library. Let me jump into basic concept of ADAMS car. So simply speaking, what is about of the data workflow in ADAMS-CAR. Simply speaking, you will be able to build up two types of assembly in ADAMS-CAR. The one of that is suspension assembly, which is our goal for this webinar. And the second one is a full vehicle assembly, where the full car is then implemented and also simulated using ADAMS Solver. In case of file architecture, the same applies to the both cases or to the both cases of assemblies. So simply speaking, I would like to highlight that in ADAMS-CAR, you need to focus on the three phases of your input files. The first of all is the template file, which describes you the topology of your model. Topology means the list of your components, like a lower control arm, like a knuckle, like a T-rod, like a tire, for example, and so on. And you need to specify the hard points table in this template file. And this will be like your input file for a generation of your model. Afterwards, based on your template file, you will then create the subsystem file. So subsystem file is again the representation of your model, but it uses the template file. And in subsystem file, you need to provide the detailed information of your model, because this subsystem file will be then used into or during the assembly process to get the full assembly of your multi-body model. And it could be then suspension assembly or the full vehicle assembly. One additional thing to mention, that template file and subsystem file are used during the modeling phase. So you cannot simulate the template or the subsystem. But if you then build up your assembly file, you will be able to solve. And so start and solve the equations, and in the end, you will be then getting the result file and post-process them into ADAMS post-processor. Next, model hierarchy, which is also crucial in case of assembly process. As you can see on the picture on the top of the slide, you have already the suspension assembly included into ADAMS-CAR. What it consists of: the suspension, steering subsystem, powertrain subsystem, and of course, what we have below, I try to highlight the whole phenomena, which is also including the test rig. Test rig means I have the two contact patches and also the tires. Both are of course in the contact. So when you apply the vertical excitation into your model, then you can run this analysis and to see how it behaves, which kind of influence you will then get on the compliance matrix, for example, in case of bushing elements and so on. Just to mention again, you can see the blue arrows. This is the representation of our communicators, and this is really important thing during the assembly process, because you need to know that each subsystem has to be in the connection to the other one. Like a suspension template, you would like to know where is my, if contains some T-rod parts, I need to know where to connect these T-rod to my steering rack, for example. And this kind of information is provided via communicators. Going further, so model hierarchy again, but for the full vehicle assembly, as I said before, we have two types of assemblies. And this respect, at this stage, the model looks a little bit more complex, because we have already the full vehicle car, like the front suspension together with the tires. The same applies for the rear suspension. We have anti-roll bars, front and rear, and also some aerodynamics components included into the model. Again, in the middle, we have a test rig, which is again the subsystem or also the template which apply the signals into our vehicle. Via test rig, you will be able also to run the full vehicle analysis, means to add the acceleration signal, to change the braking, to change the clutch or even the gear in our gearbox. And all this stuff are, let's say, corresponding via test rig subsystem. Yes, as I said before, today it's a topic of the suspension assembly, so we will be focusing mainly on the suspension assembly. Again, we have our picture of our front suspension assembly together with the steering. On the right hand side, you can see some already some animation from analysis where the opposite wheel travel has been applied into it. In case of analysis, you will be then running some quasi-static analysis covering the kinematic and compliance factors like parallel, opposite, or single wheel travel. Also, steering can be then taken into account, or if you want, you can also run the dynamic scenario and putting the vertical excitation on your test rig. And again, if I'm saying test rig, you can also apply the vertical excitation on the contact patch. So where do you have a contact point between the tire and the contact patch, or you can also apply the vertical excitation directly into the spindle part on the wheel center as well. Just to highlight again the Adams car model structure. So as I said before, you starting a job in using Adams car, you need to create a template. Template means the topology of a specific subsystem. It could be the steering, suspension, or the chassis. And in the template, you need to define the hard point table, the list of your parts. For sure, at the beginning, it could be the default mass and default inertia, but you need to create the constraints between the components, means where do I put the spherical joint, where do I put the bushing elements, for example, what about the state variables and force elements like a spring and damper again, and of course the communicator. The communicator phase must be done in the template phase. Afterwards, based on the template design, you will be switching to the subsystem. So it's a implementation of the templates and contain the different information. So means in the subsystem, you will be using your reference file, which will be the template. And of course, it's more related to the final stage of your model. Afterwards, the third phase will be the assembly process, and assembly will then use your subsystem, and assembly, of course, contain all elements required for a simulation. Yeah, depends on the type of the assembly. Will be then getting the full vehicle assembly or a suspension assembly in this respect. Next, template versus subsystem. Because as I said before, template defines the topology of your model. And this is the thing that you cannot change in the subsystem. So if you like to apply some changes, you need to come back into template builder and apply the changes. Therefore, subsystem redefines parameters and to create an instance of your template. Yes. So we have, let's say, the big advantages that based on one creation of your template, you can create, for example, the two subsystem. Let's say, for example, I have created the template for my double wishbone suspension, and this suspension can be then used for front subsystem and the rear subsystem. So that's the flexibility which can be offered during the modeling process. What I can edit again, so if you would like to modify something, this kind of changes could be only done in templates, not in subsystem. Just to mention that we have also the priority. So if you would like to now run the analysis using the already created subsystem in your assembly, then the higher priority of your parameter has the subsystem in this respect. What I would like to recommend is, simply speaking, do not start with on your own with building up your own template. It's highly recommended that you will use the template already created in ADAMSCAR, because we have a library for that, and you can use this already created template with the whole communication signals, and based on that, modify them based on your requirements. Yeah. So also touching some parameters, some state variables can be really risky, and also causes problems during simulation. Yeah. So that's also the point which I would like to mention here. Data storage. Adams files are stored in one of the three locations, depending on the type. First of all, the home directory, which is the location on your computer where the configuration file is located. Afterwards, maybe that's more important for you, the database. Simply speaking, the database folder. So with the extension of the CDB, it's simply speaking the car database directory, which contains a lot of separate subfolders. The main are, for example, the assemblies, exactly the subsystem with the point sub files, and exactly the templates as well. The other important subfolders are, for example, the roads, or the springs or damper tables, where you have property files, means the representation of your force elements, and based on that, you are, so during the building up the model, all files that you are, let's say, storing in your model preparation will be then landed in this separate table files. Working directory, that's a little bit different. Let's assume you have got already the model from the car database. You create an event, and you have tried one simulations. Yeah, just after the simulation, you will get then the solver input files, and of course your results. And these output files are then outputted in the working directory. So they will be not landed in your database. Yes. So that's a little bit maybe at the beginning difficult to understand, but do not be surprised if you closed your Adams session and then your results are gone because they are not saved. Yeah. So that's only after the generation, only the model is, let's say, saved in your database, but not the results that you have created. We will then tackle simply speaking, the suspension assembly. So as I said, after starting the ADAMSCAR session, you will then create a new suspension assembly by putting a symbol name of your assembly. Afterwards, you need to at least select one suspension. So this must be the role of the suspension, and it's a mandatory for your assembly. Additionally, you can also add different or other subsystem, like a steering subsystem or anti-roll bar subsystem if you want. By activating the other subsystem option, you will be able to add the anti-roll bar or powertrain if needed. In case of suspension assembly, we have only the one choice for the test rig, which is the suspension test rig. Exactly, these two contact patches are located on the below on side of your suspension. Exactly, in case of suspension assembly, you need to know that what we have seen on the previous slide, it was also that we can see the tires located there, and also for the tires we need to specify some values. In this respect, I meant a tire unloaded radius. The tire stiffness must be also included, and of course the wheel mass. Yeah, if some property files is already available, like F tire, for example, or different kind of tires, if you have it already, you can use the pull down menu just like here and put your property file to get the complex representation of your tire model. The second bunch of data that you need to provide for the suspension assembly, it's the vehicle parameters. So I need to put the value of the sprung mass, center of gravity height, and the wheelbase distance. Afterwards, yes, the first setup is done, and you are ready to perform the hull vehicle analysis. In this respect, you will be ready to run the quasi-static analysis, and I, simply speaking, put the types, what is then available to run into Adam's car, so like a parallel wheel travel, opposite wheel travel. Of course, you can also apply the motion on the steering, just like that, if the steering subsystem is also included. And then for this kind of analysis, you can apply the steering wheel angle or the rack displacement on the steering rack if you want. If the simulation is ready, so it's of course you can, simply speaking, jump into Adam's post-processor via F8 key, for example, from your keyboard, and then you will be able to post-process the results that Adams created by putting first of all the plots and the animations to each other, next to each other. Of course, what I wanted to show here is that Adam's car provides to you the libraries of predefined post-processing, which is then defined via plot configuration file. Plot configuration file is an ASCII file, which can be then edited manually if you want in any text editor. And by using that, you will then get the standard reports of vehicle dynamics reports, like tow and camber angle, like scrub radius, Ackermann angle, and so on. So you don't need to again start from scratch to prepare your complex post-processing. You will be able to, simply speaking, import the plot configuration file and see what about the performance of my design, which I prepared during the template and subsystem and assembly process. Creating a load case, it's also quite useful thing if you would like to run basically a way of scripting suspension simulation. So not only one simulation, but for example the different cases of your analysis, like a wheel travel, steering, static load, or roll angle. We will also create one load case file in our demonstration for full analysis or during the braking in this respect. As I said before, also, if you would like to run or make a switch from the quasi-static analysis, you will be also able to jump into dynamic suspension analysis to capture the effect of transient forces or even the damping if you want. If you have some compliance elements in your suspension assembly, like a bushing elements, for example, it's also possible to incorporate the vertical excitation defined via physical test. In this respect, you will be able to import the RPC3 files into it and also run the same scenario in Adam's car like you did, for example, on the physical test rig. Warning message, just also, quite important information. When you create the assembly, afterwards, Adam's car pops up the information window about the warnings. Of course, it does the assembly process. So assembly process means, again, the merging of your subsystem into one assembly together with a test rig, yes. And many times you should, of course, read carefully what is then written out in this warning messages, because as I said before, the main thing here is about merging all the communicators. We have the input communicators and the output communicators. And if you have a pair, input versus output, then everything is, let's say, merged together, and the model will, let's say, work properly. It could cause some problems if the input communicators cannot, for example, find the output communicators. And when this happens, then Adam's car connect your communicator and correspondent component into the ground via fixed joint, and so it's simply locked to the ground part and cannot be moved. Yeah, so it could work maybe partially properly in case of suspension assembly, but if this happens during the full vehicle assembly, then when you try to run the analysis, you will get an error directly because your model cannot move. Yes, the movement is blocked via this fixed joint. And for example, if you have a look here, for example, like communication input communicator on the left and right side, gyro to steering, it was attached to the ground. Communication input left and right, again straight to body, it was attached to the ground. For my suspension assembly, it's already fine because I do not have the chassis part, and this steering, for example, if the steering is not available, the T-rod will be then connected to the ground, which is correct in this for this model, and the same for the strap to body, because we are running the half vehicle analysis because we do not have a body, means the chassis, it will be connected to the ground, and my model will work in this respect. But if this happens for a full vehicle analysis, then you will be in trouble because your model will not work in the end. So please, after assembly process, read these messages carefully. Yeah, that's the time for our demonstration just right now. So before we start, I would like to highlight how to access the Adam's car FSAE database from SimCompanion. So after logging into SimCompanion website, just put a Formula Student database in the search bar, and by clicking the first link, you will be able to see the bunch list of available resources resources for Formula Student database articles. Together with the input files, you will then get the documentation for that, and of course the starting input files for your Adam's car session. During my demonstration, I will use I have used following link to get the car database. So as I described before, I need to import the car database into Adam. So yeah, just go into this link. You will be able to grab the correct Formula Student car database. And for a demonstration, what I will create and analyze, it's simply speaking to perform firstly at the baseline parallel wheel travel to understand its kinematics. Afterwards, I will create the load case file and again run the baseline analysis to check the brake pull results at the steering wheel. And at the third simulation, I would like to start to do some automation task using the design of experiments for roll center height using Adam's car and Adam's Insight. That will be used later on. So let me just jump into Adam's car right now. So as I said before, maybe just to mention, I simply speaking already installed my car database. It's already visible there. So FSAE 2021. But if you download that from the SimCompanion, how to edit. So you can simply navigate to the settings and preferences. In the coming up dialog box, you will be able to add the new database in this respect. So just to put the path into it. So just maybe what I'm after is simply speaking, click the car database and then select the folder. So already alias is then created. I will not do that just right now because I already created, I already edited. So Adam's car will complain about it. So I can simply speaking cancel that. But I wanted to show you how to add the car database into the session of Adam's car. So let me just create the new suspension assembly based on our FCAA database. So let me, I already put some names to it. So just maybe put the name of our fund suspension. As I said already, I will be using our suspension subsystem. Afterwards, I would like to add the steering subsystem as well, and again the anti-roll bar. Yeah, so we have our test rig already selected, which is the MDI suspension test rig. By pressing okay, this one cannot be the same name for that. As I described you previously, by each assembly process, you will then get the message window. And please carefully read the warning message. Also, if something happened during assembly process, you will then also got some error messages. And yeah, as I said, it must be checked and to be sure that your model is exactly what you wanted to achieve in the end. Maybe just on the representation, so we can see that we have our suspension assembly, and this assembly contains 3 subsystems, which are also visible there. You can, of course, jump into separate subsystem if you want by simply clicking into it, and by activating the V key on your keyboard, will then be getting the representation of your constraints already. In Adam's car, we have, let's say, the style of the right clicking of your element, which can be then, let's say, showed and modify if you want. Maybe let me just open the representation of our bushing elements in our anti-roll bar, when you can see also the property file is then included. And by opening the curve editor, curve manager, you will be able to see the stiffness on the translational direction, and the same story will also apply for the rotational stiffness if you want. Let me just come back into it. As I said, by right click, just like here, you will then get also the help about how to navigate, rotate, and zoom our model with a T, Z, or R keys. You will be able to rotate your model, translate your model, or even the zoom model, your model. With Shift S, I would like to change the transparency mode from wireframe into shaded mode, for example. And as I said already, I need to now check my suspension parameters for this model. So already see that I would like to change my unloaded radius. Let's put it the different values of our tire stiffness. Check the tire mass. If you have some property file already, you can also apply that if you want. Yeah. So in this respect, you need to navigate into your database, and as you can see, we have a separate directory, tires.tbl, so tires table, and you will be able to also use the complex representation of your tire model. For my demonstration, I'm simply using the values of the unloaded radius, tire stiffness, and the mass. I would like to also change a little bit the vehicle parameters. For that, like that. And as I said, firstly, I would like to simulate maybe one thing more again. Of course, you can also adjust the toe and camber angles if you want. Suspension, design options in this respect. Exactly, toe angle. Yeah. So if needed, of course, you can also check just for a demonstration. I would like to change my toe angle to see how does it change it at this moment, for example. Afterwards, I have also the possibility to change the camber angle as well if needed, and so on. Now I would like to, simply speaking, simulate my suspension assembly. So in case of suspension analysis, we have different types of possibilities. Let's start with the parallel wheel travel. Just to select the directory again for my results. So runs DOE, for example, why not? I created that before. I would like to put my results in this directory, some number of steps, and just move my suspension assembly plus 50 millimeters and minus 50 millimeters in bump in ribbon travel. Let's simulate it. So after simulation, I am able to run short animation directly into Adam's view to see how my model, simply speaking, behaves for first shot. If you want to create a different post-processing, you would like to go into post-processing window, and then, as I said before, just to, you can first of all maybe split a window of your post-processing. On the left side, I am able to, let's say, put the animation of our model. On the right side, I can, simply speaking, put some results as well to see how this force, for example, it's behaving. What I'm after during the presentation, I thought that I would like to use some predefined settings or predefined post-processing. By using that, I would like to import some plot configuration file from my database. So as I said, after the installation, you will then get additionally in Adam's car ACAR shared and ACAR concept standard models. And for example, from ACAR shared, you will be able to import some first plot configuration file like this MDI suspension short representation. And after think, okay, I already got the separate pages in my plotting view, and I can, for example, investigate how toe angles look like regarding the wheel travel. Of course, if, for example, I'm not, let's say, happy with that, I can also import the different one. Simply, just to mention, if you would like to import the plot configuration file, you need to switch from animation mode into plotting. Yes, then animation will be then deleted, but I am able to get the option for an import of plot configuration file. So now let's put the different one, maybe the, simply speaking, the MDI suspension parallel wheel travel. By importing that, now I got quite longer list of our predefined post-processing results, which are crucial for vehicle dynamics engineers, like a script radius, for example, which was not visible before, toe angle and wheel rate angle, for example. So that's our, and again, I can of course split our window and again put the animation next to our plot, and again play that and see how this results is changed during the animation. The second thing what I would like to add to it, we said we would like to check the pull or perform the pull analysis to measure the brake pull at the steering wheel. For that, I need to specify the load case file for that. So let's assume that we would like to have unequal braking forces to simulate braking under steering wheel angles. And we are assuming some deceleration rate. We have our brake ratio, front 55%, brake ratio rear 45%. Of course, we have already our vehicle mass there, so we can calculate manually first inputs for our load case. Yes, so I did that, and now I would like to put these values in our load case. Let's put it like right now. So how to define that? I need to again navigate to the setup, suspension assembly, and create a static load case in this respect. If you select the load case type static load, you will be able to select the braking. For example, it was 338.75 for both cases, and we need also again the force for the second one. For the right side, I put it the same. And what after I would like to change the steering wheel angle. So let's put it minus 180 degree to plus 180 degree in the 15 steps, and I need to create the name of my file. This is quite important thing, because as you can see, just in the bottom side, I have in the taskbar already the default readable database, which has been chosen like our FSAE 2021 database. So therefore, if I would like now switch to and run this analysis using the external files, which is my load case, then I need to know how to find out this load case files. And this is not, of course, not in our Akershare database, but exactly in our FSAE 2021. And just to, let's say, take the last one, put it there, and simulate right now with this load case, which was the baseline model, for example. And what I would like to see right now, of course, we can also play the animation to see what is happening. We have our braking forces on our left and right side, and we have again our steering input angle, which is then changed. Let's jump into post-processing and clean a little bit our workspace for that, because I would like to, let's say, in that respect, simply see how our steering wheel angle input. Just a moment, I need to find out wheel input torque exactly. First of all, the change during the sorry, this is wrong result. It must be from the last one. Let me jump into again with input and torque, and we would like to highlight them via steering displacement, which is the steering wheel angle. And now I can see, okay, how much torque our driver needs to pull the steering wheel angle during braking analysis. And we can see that this, let's say, values changed from minus 4,000 Newton millimeter into the 6,000, almost 7,000 Newton millimeter. And to make it life easier, we would like to apply some changes and see if our driver will be then having the easier way to make a turning or brake together with a braking into a curve. So by doing that, I would like to apply some changes on my control arm. In this respect, I will simply speaking jump into the front suspension and then find out the right hard point on the upper control arm. In this respect, I would say outer side, exactly here. You can find them via tree view, or even simply speaking modify them and apply some changes. Let's put it 700 to make it mode outward from the. So now we have a different setup of our analysis. Let's simply speaking create the copy of that and change the name that we have a modified representation and run it, yes, to see how it behaves just right now. I can simply speaking directly jump into postprocessor, and by selecting the modified value, I am able to again to see the influence of our steering wheel input torque. And now, okay, so it's let's say what I wanted to achieve. Of course, we have now the reduced value of our input torque, and it was reduced from 4,300 Newton millimeter into 1,500, 600 Newton millimeter, and the same on the other side. So of course, that's behavior. What I wanted to achieve is, let's say, done. And yeah, of course, like this changing of our design position of our upper control arm has influence of our stability. Of course, it will then have influence of our scrap radius again. And in this respect, our goal is, of course, to have, let's say, the better performance during the braking scenario when the car will be, for example, located in the curve, to have the better performance on your simulation results. Just jump into. I don't have so much time, but I will try again to jump as a third type into DOE study, what I mentioned in the presentation. So how to do that? Simply speaking, we will use again our previous stage of our model, which has been used for first study, but I would like to put that again into our design position for that, because currently I did change manually, and I would like to automate that, yes, and also check different results like roll center, for example, but by changing that automatically and to make Adam Solver busy in this respect. So let me just modify our suspension parallel wheel travel and put, like, let's say, our design position in this respect. We do not need such much steps for that. Again, so that's our, let's say, the baseline study for our DOE experiment. Afterwards, I would like to create, because we have our inputs, but I would like to, in case of DOE, create our objective in this respect. And for that, I would like to find out the one already created result. It will be the roll center location, just from the vertical location. Just put in the name, for example, that will be roll center height, like our objective, because we would like to run the different setup by changing the position of our upper control arm and to see how this change will then apply or the changes in our vertical position of our roll center height. Value at the simulation end, yes. Afterwards, as I said already, I would like to create the Adams Insight experiment that I will use our already created events like this test one. We can put our experiment just like that. And by clicking OK, you will be then switching from the Adams car environment into Adams Insight environment to create your experiment. As I said before, I would like to change the hard points of our upper control arm for the exactly front and the rear position. So the input position is the Z position. I need to promote them into the factors. As I would like to change them, let's say simultaneously, I can also tie them into one factor, because I would like to change only the one side, and the other side will be also changed as well. Let me just maybe change this will be the front upper hard point location to be more understandable for me. And paste. I would like to vary with from -50% till 50%, like the input. What I need for my DOE is also the objective, which I just created in the previous step in Adams car. It will be our roll center height. We can also promote that into the study. Just put again the proper name for that. Apply, and then we can create our study sweep for our DOE. Apply the integration design specification strategy, the model, and create the workspace. So that means our Z location of our upper control arm will be then changed via 20 trials from 180 millimeters, then 536 millimeters. And in the end, by each simulation, I will then get the roll center height. Let's save it and close the Adams Insight, because my experiment is already created. And by using the simulate and DOE interface, I can run our analysis by using just created experiment file, display insight when finished, and load analysis results in the end. So as I said, I would like to make it busy right now. So I do not have to manually change the position of our upper control arm. So I'm getting the whole setup just by automation from Adams card directly, together with Adams Insight. Then Adams Solver is performing the analysis and importing results in the end into Adams Insight. So when the trial 20 will be then ready, we'll be able to post-process our results. So which is currently doing. So as I said, I requested to open the Adams Insight after finishing my experiment. We can also see already our results, how roll center height was, for example, changed. We can fit our results and optimize that. Simply speaking, I would like to see, okay, we have our changes from the location. So this was our input variable. And of course, we have our design objective, which was the roll center height. So by doing that, I can simply speaking, based on the workspace and the simulation results, what I did in Adams, we can also have a look on that. Just like that, we have our separation analysis directory. You can see that you have 20 trials of our results, which are, let's say, made automatically, and it was automatically imported into Adams Insight. Afterwards, I simply speaking would like to see, okay, which value, if I put, for example, I would like to achieve the 0 millimeter target of that, which value of the front upper control arm I need to put in the Z location. The same for the 50 millimeter, for example, I can also run and got the value, and the same for the 100 millimeter, for example, I'm also getting the different value for that. And exactly what I put in the presentation, it was like, sorry for that. I would like to simply show it just like that. I create this table based on my design of experiment results. So by selecting my target, I got the upper control arm hardpoint Z location. Concludes my demonstration, and sorry for a little bit longer session, but I would like to now hand over to Alex.
Okay, no, thank you. So I just want to point out a few resources that all of our students and student teams have. So if you're not already receiving a Hexagon software sponsorship for your student team, you can apply for one online. It's as easy as following the link on the screen or searching Hexagon Student Competition Sponsorship and then filling out the online form. This gives you access to the tools that professional engineers use regularly in their jobs. If you just want to try our software or just a student, and we would recommend that you register for our free student editions. Again, you can follow the link on screen or search Hexagon Student Edition. Then register with your student ID or some other document that demonstrates your current student status. And the student editions, they are more limited than what would be in the student competition sponsorship. Like they're limited by their model sizes. Additionally, Adam's car, which was shown today, is not included in the student edition. For that, you definitely want to apply for the student competition sponsorship. And today was focused on a front vehicle assembly. Next week's webinar will explore a full vehicle assembly suspension. And you can see the table on screen showing our kind of remaining schedule of webinars for this series. And again, today's webinar, like all in this series, was recorded and will be uploaded to our YouTube channel. You can expect the video to be uploaded in about 24 hours. And in the description of that YouTube video, there will be links included for the demo files today, as well as how Christian already showed you how to access them. And for the latest academic resources, please follow Alex Sainte-Marie on LinkedIn. And with that, I think I'll turn it back over to you, Christian, for some Q&A.
Okay, thank you so much. Yes, so I think we can just start the Q&A session now, just right now. Thank you.
Okay. It looks like we did get a question from B, and this person was asking, how should you model inboard control arm joints if they are both spherical bearings? And then he or she also goes on, would you model them as bushings or spherical joints?
Exactly. If I would like to do it like you would like to have it, then I will go for a bushing representation where you can apply the 6 degrees of freedom model, including the stiffness. So the translational stiffness in X, Y, and Z direction, and the same rotational stiffness in the X, Y, Z direction, also including bushing property files. You can incorporate damping effect if you want, so not only the stiffness, and preload if needed. So I will go for a bushing element at this position.
And then you showed a few ways of modifying the hardpoints within Insight for creating that design of experiments. Would you also be able to add additional hardpoints? And if so, would you do that through Insight or in the subsystem?
So no, so Adams Insight is only like an execution of your model. So based on the Adams car model, you are doing the switch from Adams car into Adams Insight, and you are running your analysis, you are running your simulation. So you will be not able to add because you have already created setup. If you need the different setup of your model, you need to jump into Adams car again. So because that's your model representation, and as I said already, if you like to change the model like a hard point, because hard point It's, let's say, you can only, in a subsystem level, you can only modify the hardpoint representation. Means you modify the location. But if you would like to add the new one, you need to jump into template. Yes, and in template, you can now, let's say, let me just open some template from that, from Formula Student again. Let's say open the front suspension, and here you have, of course, the hardpoint table as well, but you have the possibility to build the new hardpoint, which, let's say, it's not available in the subsystem. Let me just jump in or switch the view. You can see that I do not have the possibility to build. I have only the possibility to adjust my setup. So that's also the phenomena what is, let's say, included in Adam's car. In a template is like a saved representation of your model, and it contains your topology. And in the subsystem, you have, let's say, the detailed information, like the parameters. They can be changed, but you cannot add. You cannot add the new one. You can only modify them. So that's the thing. So if you would like to make some changes, you need to jump into template, add missing point, let's say, based on the template, create a new subsystem, and then you will be then ready to run the new setup. So that's the way you will be doing with that.
When you were looking into the different subsystems, there were parameters and inputs. Where would a user go to find what units are being expected? Like the tire unloaded radius or the wheel mass.
So in case of the suspension assembly, it's a little bit different because you have the suspension without tires, without tires, because tire here is like a part of the test rig. And to find out how to change that, you need to navigate to the setup. Afterwards, navigate to the suspension assembly, and you will find suspension parameter dialog box. And by opening that, you will be able to change the settings of your tire model. And as I said already, so this is only the, let's say, the 3 values of our tire, but you can also, let's say, put some property files like a representation of your tires. Let's put it just like that. I would like to see, for example, my Pacheca, so based on the Professor Pacheca, with the belt dynamics representation. And you can also, let's say, put this representation as well, which will be, let me just open it just like that. If you would like to see how does it look like, even the front tire, this is not what I wanted. I wanted to just see how it looks like via the Notepad+ editor. So you can see that this is this tire version. You have, of course, the settings of your, so the dimensions of your tire model, again, which units, which vertical stiffness, the damping effect is also included, and other values, yes, to develop or to provide the right representation of your tire. So this will be like the second stage for the model fidelity of your modeling, yes, if you want. Of course, you can start with some start values, as I said, wheel mass, tire unloaded radius, and the tire stiffness. But if you would like to, let's say, have the more reliable model, you will go further and implement or use, simply speaking, the property file of your tire.
Okay, thank you. No, that helps a lot. See where all the units are coming from. And we did get a couple more questions in the chat. So there is one from Omar. Where would the origin be for all the hardpoint coordinates?
Yes, we have this you mean, yes, of course. If you open so of course, in each, let's say, subsystem assembly, or even the full vehicle assembly, you can also see like this orange coordinate system. And this is exactly our, let's say, original reference frame. It's always located on the ground part, which is also our reference part, and the location is 0, 0, 0, and the same for the orientation. Yeah. So that's the reference coordinate system located in Adams.
Yeah, thank you. And we do have another question from Brighton Plant. This person is new to Formula SAE and suspension geometry. They're still learning a lot. After I get access to Adams software, how do you suggest I get comfortable with the program? Which resources would you recommend?
So as I said already, please use the links which are also included in my presentation and will be shared later on to get, let's say, the whole representation of available resources. And by using that, you will then start with the step for step. So first of all, suspension assembly, using the exactly what I have used for my demonstration. And afterwards, of course, you can simply speaking from then you can also, what is available here, I didn't mention that, but if you open your FSAE 2021 database, you have already the front suspension assembly already connected to each other. You have also the rear suspension exactly. You have also your full vehicle with the aero components. Let me just open it. No, I would like to just open from the scratch. So means, as I said, Sim Companion website. Look for the link to the database FSAE database in Adams car, and by using that, you will be able to run and get just like that the database with the running model, means our full vehicle assembly, where you have also the chassis part, you have also the tires, the steering as well, the rear axle with the drive shafts again. So you have a powertrain inside, and you can run this model, and for sure it will be let's say the quicker learning curve to achieve to get the runnable and runnable model on in your learning phase, for example.
We did get another question from B. I think that this might fall into next week's webinar topic, but do you have any recommendations for modeling a decoupled roll heave system?
I cannot really answer this question. It's more related to the fuel vehicle assembly, and as you said already, it should be then answered later on in our upcoming webinar. Sorry for that.
Okay. V, I hope you can make it to next week's webinar, where I think we'll be able to give you a better demonstration and answer. And we did get one more question from Salvatore Papa. In which format can I upload 3D model files into the Adams environment?
Actually, the Adams is quite well open for different CAD formats. As you can see, you can import pretty much each CAD format, like a CATIA, like Inventor, Pro Engineer, SolidWorks, and which is, let's say, the step file, which can be also, let's say, important if you want, or Unigraphic. So in my opinion, you don't have any limitation in case of importing your CAD geometry into Adams. As you can see, you can simply navigate to the file and import, and changing file type from the CMD, which is the standard or default input file, Adams View command file. Scroll down a little bit, you will then find the different various type of CAD format that it can be imported into Adams. I do not see any problems with that.
No, I don't think so. No, thank you. Thank you for answering that. And thank you to everyone for all of the great questions. I'm just going to confirm that, okay, Salvatore was just giving their thanks for your answer. And with that, I think we have exhausted all of the questions. And so I would just like to give a big round of thanks and applause to you, Christian, for taking the time to give this fantastic demonstration.
Thank you very much. It's really, so it was a pleasure. I really appreciate it that I was able to contribute in such webinar series. Thank you very much also from my side for your time.
All right. And with that, I'll end the webinar.